In this video, we are going to discuss question based on changing the angle of incidence. The question says a ray of light strikes a plane mirror at an angle of 52 degree to the normal. The mirror then rotates 35 degree around the point where the ray strikes the mirror so that the angle of incidence of the light ray decreases. The axis of rotation is perpendicular to the plane of incident and reflected rays. What is the angle between initial and final reflected ray? So here you have a plane mirror and a ray of light is incident at the plane mirror making an angle of 52 degree with the normal. So this is the incident angle and I can write theta I, which is the angle of incidence for the initial position of the mirror, to be equal to 52 degree. If the angle of incident is 52, angle of reflection will also be 52. So this angle right here will also be 52 degrees. We can write theta r, which is the angle of reflection. Initial value is 52. The mirror is then rotated about the point where the ray of light was incident by 35 degree. So this angle right here is 35. If the mirror is rotated by 35 degree, the normal to the mirror at the new position will also be rotated by 35 degree. So angle between these two normal, which I can write as delta theta m, is 35. This angle will be represented by green. Now, if the position of normal changes, the angle incident ray makes with the new normal will also change. The normal is shifting towards the ray of light, so angle of incidence will decrease. This is the new angle of incident shown in blue. And I can find this new angle of incident by subtracting the original incident angle, the initial incident angle, with the change in normal. So I can write theta I final to be equal to theta I initial minus the difference in the mirror position, which is equal to 52 minus 35. That will be 17 degree. So the new angle of incident is 17 degree with the new position of the mirror. If the angle of incidence is 17, according to the law of reflection, angle of reflection will also be equal to 17. So the new angle of reflection, that is here, is 17. The question is asking me to find what is the angle between the new reflected ray and the original reflected ray. So I need to find the angle in red over here. So looking at the figure, we know the difference between the angles of reflected ray, which can be written as delta theta r, can be found by adding the original reflected angle, which is this region here, plus whatever is left above the original normal, this region in green. So original angle of reflection I know is theta r initial. I need to find this angle, this small region here. Now how do we do that? I know the angle between the two normals, which is 35. And I also know the angle between the new normal and the new reflected ray, which is 17. If I take a difference between these two, I will get the smaller angle right here. So I can write this as theta Ri plus 35 minus 17. 35 minus 17 will give me the smaller angle here. So now we can substitute theta Ri is 52 plus 35 minus 17. That gives me delta theta r to be equal to 70 degree. Now, if you don't want to use the geometry of the figure, you can remember a simple rule. Change in the angle of reflection will be equal to original angle of reflection, so theta Ri, plus the change in the mirror angle, which is 35 here, minus the new angle of reflection, so theta Rf. This will give you the change in the angles. So if I were to substitute this, I get the same value here. So to use this, all you need to find is the new angle of reflection, which can be easily found by finding the angle of incidence.